Good morning, Algebra 2 students. This is preparation for you for Opportunity 9.1 through 9.3. Okay, so I'm going to work a few problems, 8 of them all together. I've done some of the work beforehand just to try to shorten this video up. These are exactly the kinds of problems that you are going to see on the opportunity itself, so hopefully you can use this. This will help you work some of those problems. So I just want to, and what we're doing is we are solving quadratic equations or equations that are quadratic in form. And depending upon the structure of the equation, we approach it in different ways. Okay, so let's leap right into it. Okay, we can use the square root principle. Square root principle helps us to solve quadratic equations in certain forms. So for instance, if I had something in this form, okay, so we're going to start from the simplest and work towards more difficult. So here, for instance, is an equation that is in this form. And so, of course, what I would do then, using the square root principle, is I would just take the square root of both of these. Now, let's take a look at 50. I'm going to break this up. I'm going to find the perfect square in it. And 50 is 25 times 2. All right, so there is a perfect square inside here. So the square root of x squared, remember there's a 2 here because it's a square root. And so it's really x to the 2 over 2, x to the first. So here we go. And here, the square root of 5 is going to come out. And this is going to be plus or minus. Okay, all these, in fact, are going to be, well, at least when we're applying the square root principle or completing the square, we're going to find that they're plus or minus. Okay, and so that comes out, and there we go. So x is plus or minus 5 times the square root of 2. If I square this, then I'll get 50. Okay, all right. Let's take a look at one that's in this form right here. Okay, so ax squared plus b equals c. If I have one that's in that form, here we go. All right, so what do I want to do? Well, let's isolate the square. So I'm going to subtract 11 from both sides, and I'm given this. Now this is back in that form right there. Well, here, let's go ahead and divide out the coefficient. Okay, so when we do that, now I have taken this and put it back in this form. So all I'm going to do is take the square root of both sides, and of course the square root of x squared is just x. And here I've got a perfect square inside there. Okay, this would be 9 times 3. 9 is a perfect square. Okay, so this would be plus or minus 3 times the square root of 3. Okay, so x equals plus or minus 3 times the square root of 3. Okay, we all got that? Well, what if the structure is a little bit more complicated? Let's say that it's like this, okay? And you're going to be given things with these sorts of structures, or you kind of have to move things around a little bit to get that sort of structure. So let's look at this. I have a binomial that's squared, and then I've got the constant over here. So in this case, I'm just going to take the square root of both of these again, and the square root of 4x minus 5 squared is just going to be 4x minus 5. Now over here, let's break this thing up. So I'm going to take the negative 1 out. Remember, the square root of negative 1, this imaginary number, is going to be I, indicating it's an imaginary number. And I have 4 and I have 3. Okay, if I break it up, here's my perfect square. Okay, so the square root of 4 is 2. 2 is going to come out, and the I is going to come out. Okay, so 2i square root of 3. Okay, got that? As a matter of fact, this is going to be plus or minus 2i square root of 3. All right, I'm going to move the negative 5 over. Okay, so when I do that, I'm going to have 4x equals 5 plus or minus 2i square root of 3. And then I'm going to divide by 4. Okay, so when I do that, okay, here we go. And as far as I'm concerned, you can leave it like that. If you want to split it up into 2, so you'd have 4/5 plus, and this would reduce plus I square root of 3 over 2, or minus square root of 3 over 2. You can do that if you want, but if you want to just leave it like that, that's perfectly fine. Okay? All right. Well, let's look at something that's in this form. And if we have something that's in this form, think about it. If you move the C over, you have something that's in standard form. Okay, and that's exactly what we're going to do. So here I've got something that's in this form. Okay, well, this is in standard form. So I'm gonna put it in this form. I'm gonna move the 29 over. I'm gonna add 29 to both sides, and here we go. Because what I'm gonna do then with what is left here, and you won't always have to do this. If the 29 was over there already, then you don't have to do anything with it. But what I'm going to do here is make this a perfect square trinomial by doing something called completing the square. And I'm going to need a little bit of room over here to finish this thing off, I think. Okay, so I'm going to complete the square. So I'm going to move the constant over, so now I've got it in this form. So I take this, B, okay, so 8, I'm going to divide it by 2. 8 divided by 2 is 4. Then I'm going to square it. Step 1, divide B by 2. Step 2, square what I get. So 8 divided by 2 is 4. 4 squared is 16. Then I'm going to add 16 to both sides up here. So when I do, what I've got here now is a perfect square trinomial. Okay? And a perfect square trinomial has a particular pattern that you can factor. It factors into, in this case, this one will be x minus 4 times x minus 4, x minus 4 squared. This combines to be 45. So now look what I have here. I've got something that's in this form. Okay, so I have completed the square in order to get something now that's in this form. So what do? Well, I'm going to take the square root of both sides. When I do, the square root of x minus 4 squared is just x minus 4. And let's take a look at 45. 9 times 5. Okay, so here's my perfect square. So plus or minus 3, square root of 5. I'm going to add 4, so x equals 4 plus or minus 3, square root of 5. All right, so there we go. Here's the solution to this. All right, let's take a look at quadratic formula. I'm not going to go over this much. Here's the quadratic formula itself. You'll have 3 problems, I think, in which you're going to have to apply this. So let's say I had something in this form. I need to put it in standard form. So if I put it in standard form, here we go. And then it's just a matter, here's A, here's B, here's C. It's just a matter of taking those values and putting them in the quadratic formula. And I'm already at almost 8 minutes, so I did it, and I would get that x equals 2 and negative 3/4. The quadratic formula, if you put something in standard form, when all else fails, see, if we had this, we wouldn't be able to factor it. We couldn't factor this thing by hand. Okay, it just doesn't work. So any polynomial that's not factorable otherwise, that's quadratic, you can stick the coefficients and the constant in the quadratic formula and you can solve it. Okay, you are going to have some problems like similar to this. If I had something where I have rational expressions, okay, I need an LCD. In this case, the LCD would be x times x minus 1. When I apply that, so just trust me, I've done the work here already. If I apply that, do the distribution, combine like terms, move everything over to one side, I get this. I have a GCF, so I factor it out. I'm left with this. When I factor it, I get that x plus 5, x minus 4. So x could be negative 5 or 4. Okay, so something like that, you can expect to see something like that. Okay, here, what if I have a radical in it? Okay, so if I had a radical, I'm trying to solve this thing. I'm going to isolate the radical first. So I'm going to, in fact, in this case, I'll just move it over. So I have 2 times the square root of x equals x minus 3. I would square both. So, okay, I'd square both to get rid of the radical. I'd end up with 4x. I have to FOIL this thing. There we go. I'm going to move everything over to one side, and when I do, so in this case, I'm going to subtract 4x from both sides, so I end up with this trinomial. I factor it, and I find out that x equals 9 or 1, and you'll probably be asked to check if there's any extraneous solutions, and 1 is extraneous. It does not lead to a true conclusion. All right, I have one more. What if I have negative exponents? So let's come back over here, and I'm going to give myself a little bit of room right here. So let's say that I have the following problem. That I have 1 plus 5x to the negative first plus 6x to the negative 2 equals 0. If I have that, okay, let's get rid of the negative exponents first. So I'd have 1 plus 5 over x. Remember, this exponent has nothing to do with 5. Okay? X is being raised to the negative 1 power, not 5. Okay? If there were parentheses there, that would be a different thing, but there are not. Same thing here. So this would be 6 over x squared equals 0. So what do? Well, I need to multiply through by an LCD, which would be x squared in this case. And if I did that, then I would get x squared plus 5x plus 6 equals 0. This thing here, I could factor it. Okay, so x plus 3, x plus 2. So x could be negative 3 or negative 2, and as far as I know, neither of those are extraneous. All right, so these are the kinds of problems you're going to be confronted with. There's an example of just about everything that you'll see or something very similar to it, so do the opportunity. Use the video, Use the tools you have at hand. It's open note, it's open book. There's no reason that you should miss anything. Some of you are not taking the opportunity to use the resources that you have, and it's to your own discredit, all right? So use the things that you have available and get it done.